Good evening, students. Today, as you can see on the screen, we will be doing complex numbers. Now, since it's a weekend class, we'll be more focused on the solving part. That means on the questions, on the numerical. But before that, also let's quickly revise the basics concepts of complex number. So, what I'm trying to say is the basic concepts of complex numbers we are going to cover in this lecture are first, introduction, what are complex numbers, then the important part, algebra of complex numbers, and then lastly, modulus and argument. The remaining part, which are the De Moivre's theorem, exponential form, and all that will be covering in tomorrow's class. So, and also the our questions will only be based on these chapters, right? So, let's move on to the next slide. Next slide, we'll quickly go through the theory and then start with questions. So what is a complex number? Complex number is of the form a plus ib, correct? Where a and b are real numbers, I is under root of -1. So there are two types of complex numbers. First is real complex number. In real complex number, it means that so as we see, there are two types of complex numbers. First is only real numbers. That means imaginary part will be 0. And the second is imaginary number. That means real part will be 0. So this is what we are going to say. A plus IB imaginary. That means A is 0. After that, what we is gonna do is equality of complex number. One of the most important thing. This same thing will be trying to do will this same thing will be there when we do vectors, equality of vectors. So what does equality of complex number means? That if two complex numbers are equal, then that means the real part is equal and the imaginary part is equal. What is the real part? It is A. What is the imaginary part? It is C. Correct? A and C are equal. Got it? Yeah. So next is A and C are equal and P and D are equal as we discussed. Let's move see the example. Here if x plus iy equals to 3 minus 4i, then by equality I can say x equals to 3 and y equals to minus 4. I hope you got it. Correct? After this, we will see algebra of complex numbers. What does algebra involve? Algebra involves the addition, subtraction, multiplication, and division. So let's go through this addition of two complex numbers. What is addition of two complex numbers? That is z1 equals to x1 plus I y1, z2 equals to x2 plus I y2. What does that mean? If I add both, then basically the real part will get added and the imaginary part will get added. If we add the real part, if we add the imaginary parts. Got it? So if this is same, then what will be the z1 plus z2? If you can see, z1 plus z2 will be add the real part. So 2 minus 4 will be minus 2. And add the imaginary part. 3i plus 6i will be 9i. I hope it is clear. Let's move on to the next part. Next is subtraction. Now addition and subtraction are both similar. Similar means खाली minus sign का फर्क है जैसे multiplication and division में. So क्या फर्क है? Z1, Z2. Again, and subtraction is Z1 minus Z2. So Z1 minus Z2 will be Just subtract the real part and subtract the imaginary part. This is what we get. Next is multiplication. How you multiply? Multiplication is same as we open the brackets in algebra. And if we multiply both, what will we get? Here we'll multiply A1 with these both full bracket and A2 with this full bracket. So if I open the brackets, I will get something like this. And we know the value of I square. Value of I square is -1. That's why we got minus here. Got it? Now we'll take the imaginary part together and the real parts together. So what is the real parts? These are the real parts. So we'll take it together, and these are the imaginary parts. So we'll take that also together. Got it? So now let's take the look at division. What is meant by division of complex numbers? Division means upon. Now let me tell you division an interesting thing. Key division may we generally rationalize. Not generally, we always will rationalize. Why rationalize? Because complex number in denominator is not allowed. So if I see Z1, Z2 as two complex numbers and I got Z1 upon Z2. So by rationalizing, I can get like this A2 minus BI2, A2 plus BI2. Now in the denominator, you can see we got the format A plus B into A minus B, which is A square minus B square. So that means in denominator, I'll get A square minus B square. And the numerator part, again, same as what we did, multiplication of complex number. So we did here multiplication of complex numbers, got the real parts together, got the imaginary parts together. So and denominator, as I told you, we'll get A square minus B square. Got it? So this is the basic steps of division of a complex number. There is no need to memorize the formula. We'll just use the same step as we used here if division of complex numbers come. Then finally, we can separate the denominator or split the denominator and we'll get this. Because what is the format of the complex number? It is real part plus I into imaginary part. Got it? So that means real part plus I into imaginary. So let's move on to the next, conjugate. Conjugate of a complex number is a very important topic because we have to study properties of conjugate. So properties of conjugate are very important for solving questions. So let's look at the properties of conjugate number. Before that, what is a conjugate? If Z is A plus IB, then its conjugate is A minus IB. What is meant by A minus IB? We just change the sign of imaginary part. It was plus B, here it became minus B. So that means if we take an example and by replacing I with minus I, that was what I was talking about. Just change the sign of I. Here it is plus, here it is minus. You can see this here. And properties of conjugate, very important part. As we can see, these properties are very useful and help us to solve many questions. We'll see in some time when we'll do question. So what are the properties? First is, if we take conjugate 2 times, then it will give us the original complex number. Second is, if I add z plus z bar, we'll get 2 times real value of z. You can check these properties all. I know you already know these properties, but then too, we'll just revise the properties so it'll be easier to solve us numericals. Got it? Chalo. Let's see the other properties. I'm just listing it. First, second, third, we have seen. The fourth one, z equals to z bar, implies z is purely real. Fifth one, z plus z bar equals to 0. After that, z bar equals to real square plus imaginary. This is a very important property. Once we study modulus of complex number, I mean, you've already studied, but once we'll see, this property will again appear in the modulus part. So let us move to more properties. This says that the conjugate of a complex number is distributive. That means I can split the conjugate part to both. After this, same is for subtraction. After this, same is for multiplication, and same is for division. Got it? So we have done algebra of complex numbers. Now it is time for us to do modulus of a complex number. Modulus of a complex number we'll be studying in more detail as we progress the lecture. But just now, I'll just give you an introduction. So what is modulus of a complex number? Suppose a complex number is z equals to a plus ib. Then what is this modulus? Modulus will be under root of real part ka square, a square plus b square. B is the imaginary part. Got it? After this is what I'm talking about. Real part ka square plus imaginary part ka square. I hope you know how to read this. This is real part of z. Who is the real part of z? A. This is imaginary part of z. Who is the imaginary part of z? B, which is with I. So clearly, obviously, mod hai to modulus will always be greater than equals to 0. Let's take an example. So if z1 is this, what will be mod of z1? Could you guess it? It is mental maths. I hope you got the answer till now. If you got it right, you can check it here. It will be under root of 3 square plus minus 4 square. And that, my friends, will be equal to 5. You can see it is basically like Pythagoras. If you can relate, we'll see how it is related to Pythagoras. Actually, it comes from Pythagoras. We'll see it in the coming slides. Got it? So, after modulus, we are going to see some of the notes. Properties of modulus, that is basically, what are the first? Mod of 0 is 0. That means the complex number itself is 0. Second, this one. This is a very important property. Many a times there are questions which are directly asked using this property. Many a times in previous JEEs we have seen questions on this. What does this say is the modulus of z is equals to modulus of z bar is equals to modulus of minus z. I hope you know that modulus means length. We'll see in the coming diagram, but you have already studied. So, and we are focusing mainly on numericals. That's why I just wanted to clear this property. Modulus means length, and length does not change when we use conjugate or when we use negative sign. Got it? So, and last one. This is the property I was talking about when we studied the conjugate. So z into z bar is equals to modulus of z square. This is also an important property. Let's look at the second one. This is same as the conjugate one. We can split the modulus. Same done as conjugate. After this, same it is valid for division. This is a very important property. Z1 plus Z2 the whole square. It is similar to A plus B the whole square, which is A square plus B square plus 2AB. Instead of 2AB, we have real part of Z1, Z2 bar. And same is with Z1 minus Z2 the whole square. Just we have the negative sign. And this is a direct result to remember the ninth one. This is the generalized form of above. You can see these two properties are the same, just it is a generalized version. What is meant by generalized version? A की जगह पे 1 है, B की जगह पे भी 1 है. Got it? So now it is time for us to solve the question. Till now, let me revise you again what we have done. What we have done is two things: introduction and algebra of complex number. After doing some questions, we will look at the third part. Do you remember what was the third part that we are going to cover today? It was modulus and argument of a complex number. So it's a very basic questions here. So we can see that first, express the following in the form of a plus ib. That means just we have to simplify the complex numbers. It's a very simple question. What we can do, we'll multiply it, right? So if we multiply, I'll get minus 5 into I. So minus 5i square upon 8. What is the value of I square? It is -1. So -1 into 5 will be 5 upon 8. This is my answer. You can say these are some warm-up questions to just mentally prepare your brain for some calculations. Next, same. We have to express it as a plus bi. As we can see, we have denominator, and if complex number is getting divided, we rationalize. But before rationalizing, let's simplify the denominator. We'll get 4 plus 3i upon. What I'll get? 4 2s are 8 minus 6i plus 12i minus 9i square. What is I square? I square is -1. So it will become plus 9. 9 plus 8. तो नीचे तो आएगा 17 माइनस और प्लस 6i. न्यूमरेटर में 4 plus 3i. Now it is proper division. What we do in division? We multiply and divide by conjugate. That means I'll multiply with 17 minus 6i upon 17 minus 6i. So in numerator, 17 fours are 68 minus 24i plus 17 threes are 51i and minus 18i square upon denominator will get a square minus b square. So 17 square plus 6 square. I hope why I wrote this plus, because I'll get I square and I square will be -1. So it will become +1. Let's simplify the numerator. 18i square. I square is -1, minus minus plus. So I'll get 68 plus 18, which is 96, plus 24 plus 51. So 44, 6, 7. So I get 27i. And in denominator, what is 17 square? It is 289 plus 36. Whatever is the answer, that is 27i upon. Add, we get 15, 8, 9, 11, 12, and 3. So that is 96 upon 325 plus 27i upon 325. It is mandatory, or it is make it a habit to leave your answers in the form of a plus bi. So this is basically, this complex numbers comes under algebra, and algebra means we'll have to solve equation. So that's what we are doing. We are solving. It may look a bit calculated, but this is a general way of to solve. Next question. If z equals to cos theta plus I sin theta. This is another way to write. This basically means cos theta plus I sin theta. It is just another way to write z. What is the value of z minus 1 upon z? Let me come to this side. Z minus 1 upon z. So first, we'll find 1 upon z. What is 1 upon z? 1 upon cos theta plus I sin theta. I am writing cos theta as C, sin theta as S. So we'll multiply and divide by conjugate. Cos theta minus I sin theta. So in numerator, I get cos theta minus I sin theta. In denominator, cos square theta plus sin square theta. I hope you got it. Y plus. वो वापस सेम I square -1 हो जाएगा और माइनस माइनस प्लस. Notice cos square theta plus sin square theta, it is 1. So 1 upon z क्या मिला? Cos theta minus I sin theta. What is z? Z is cos theta plus I sin theta. Got it? So that means if I subtract z minus 1 upon z, which is a required, so what I'll get is z minus z. So if you can see, I'll get 2 times I sin theta. This is my answer. I hope it is clear. Right? Let's move on to the next part. One second. Okay. Chal. Next question. If Z is this, show that. This is an interesting question because normally what we'll do, we'll substitute the value of Z here. But instead of substituting, let me tell you, we can do it in another way, which is this way I'm going to tell is basically if higher powers come. This is a simple question because it is Z square. We can easily use squaring. But if it's Z cube, if it is Z raised to 4, which generally comes, then we'll not be able to use this method. It will be very lengthy. So pay attention how we do this. Basically, we don't want I. Here, there is no I. What does this mean? There is no I. That means I don't want I. So there should not be I. And here, there is a square term. There is a square term. So that means I need to square and I don't need I. So what I'll do is I'll write this equation as Z minus 2 is equals to minus 3I and then square it. So if you can see, this is hence proved, just you have to open the bracket. This will be Z square minus 4Z plus 4 is equals to 9I square. What is I square? It is minus 1. If I take it on the left hand side, I'll get Z square minus 4Z plus 13 equals to 0, which is the required. So mainly square term tak nahi puchte. Basically they ask till Z raised to the power 4. I hope you got it. Let's move on to the next question. This is an interesting question. Again. See, we want to prove this. Just take some time, 10 to 15 seconds to see what we have to prove. Here, we only need X. Correct? So what we'll do first, we see the division. So if we see the division, we generally always we use complex numbers ka conjugate, multiply divided by conjugate. So X plus IY can be written as 1 upon, I am writing cos theta as C, sin theta as sin, into what is the conjugate? 1 plus cos minus I sin upon 1 plus cos minus I sin. So in numerator, I'll get 1 plus cos minus I sin upon niche a square minus b square. Again, for us, it will be a square plus b square. Let's open the denominator. So 1 plus cos minus I sin upon a square plus 2ab plus cos square plus sin square. Now, what is this? Cos square plus sin square is 1. So what I'll get is 1 plus cos minus I sin upon. This will be 1 plus 1, 2. So I can take 2 common into 1 plus cos. Now I split the 1 plus cos upon 2 into 1 plus cos minus I sin upon 2 into 1 plus cos. So here you can see 1 plus cos gets cancelled. I'll be left with half plus I sin upon 2 into 1 plus cos, which is equals to X plus IY. Do you remember equality of complex numbers? Yes, we are going to use equality of complex numbers. So I'll get X equals to half. That means 2X equals to 1. If I square on both the sides, I'll get 4X square equals to 1. And finally, 4X square minus 1 equals to 0, which we needed to prove. Got it? In JEE, let me tell you, you might be saying ki show that questions nahi aate hai, but these questions can be asked in JEE. What they'll ask is they'll ask the value of 4x square like this. What is 4x square equal to? And then they'll give options. Option A 1, option B 2, option C 3, option D 0. So what is 4x square equals to? We can see 4x square equals to 1. That means I'll mark option A. So these questions can be asked like this in JEE mains. Let's move on to the next part. Yeah, this is a very interesting and very classic question, which you might also have done already, because it's such a classic question. Many a times we do this. So what is this? We have to show this, right? Again, we have to show this. That means we have to basically equate the complex number as we did in the last question. So for equating, this is 1 by 3. So I need to cube on both the sides. So what I'll get is x minus iy. I'll cube. So 1 by 3 will get cancelled, is equals to a minus ib the whole cube. Correct? If I open the cube, I'll get a cube plus 3a square b plus 3ab square plus b cube. So let's simplify. So I'll get a cube plus 3a square bi. I square is minus 1. So minus 3ab square and I cube is minus I. So minus bi. Let's rearrange the real parts and the imaginary parts. So and these two. So I'll get plus I times 3a square b minus b. And what is this equals to? X minus iy. So we can write by equality of complex number. I'll see to write. So in theory, we have to write. So I'll get x equals to a cube minus 3ab square. And I'll get y equals to 3a square b minus b. So we can take a common and I'll get x by a is equals to a square minus 3b square. And here I'll get y by b is equals to, get y by b is equals to 3a square. We made some mistake, I guess. b cube it is. Yeah. Minus b cube, so minus b square. Now we just have to add. So if we add x upon a plus y upon b will be equal to, add these, a square plus 3a square, 4a square minus 3b square minus b square minus 4b square. So let us take 4 common. I'll get a square minus b square. Hence proved. Got it? Let's move on to the next question. Okay. Questions are over. Now it's time to study modulus and argument in more detail. I told you we'll be studying modulus in more detail in coming slides. So now is the time. First is the graphical representation. So basically, z equals to, I said this notation, right? We use this notation in a sum. If z is x comma y, that means z equals to x plus iy. Now this is plotted in the xy plane. So what we get is, every point denotes a complex number. So if we plot it, then basically I'll get, we know the modulus also. Saw this. We remember the formula, right? So what are we gonna get? These are some examples you can see. Okay. Important remarks. Then we can observe z bar equals to mod of z. The property I was talking about. Z bar equals to mod of z square. Important property. This also we already saw. I am listing it again because these are such important properties. That's why. Let's move on to the next, amplitude or argument. I hope you know amplitude and argument. So same we can see here. Let us plot the point P. So this OP you can see is a modulus. What is OP is a modulus? Right? So you can see this distance is x, this distance is y. Therefore, by Pythagoras, you will get OP is equals to under root of x square plus y square. So you saw how modulus is something like Pythagoras because it comes by using Pythagoras. And what is theta? Where is theta? Theta is basically this angle which is angle made by segment OP with x-axis. And the range of theta is very important. It is minus pi to pi. What is meant by minus pi to pi? कि यहां से यहां तक तो एंटी क्लॉकवाइज गए और फिर वापस इधर से इधर क्लॉकवाइज. दिस इज बेसिकली pi minus pi to pi. Or you can say we started here and we went till here. This is minus pi to pi. Correct? Let's give what is the amplitude? It is basically tan of y upon x. You can see tan theta opposite upon adjacent means tan theta is y upon x. Let's see the next. You can see it is highlighted because it is very important. There are two names, amplitude and argument. Got it? Let's now again focus on the questions. Correct? Come on, guys. If z equals to x plus iy, then amplitude of z is lies on negative x-axis. Let's see what does this mean. This is the negative x-axis. This is a point z. This lies here. And if this point lies here, what was the amplitude? It is angle made by positive the line OP. This is O, this is P point, and this is x-axis. So angle made by positive x-axis is anti-clockwise. So what is this? This is basically pi. So my answer is pi. Correct option is 3. Next. If z equals to this, find modulus of z. Now, it has been some time, 10-15 minutes since we studied the properties of modulus. So we will be going to use the properties of modulus here. So how we'll use is, we want modulus of z. So let's write modulus of z equals to modulus of this whole thing. Correct. Now, according to the property, we can split the modulus. That means I can write modulus of 1 plus I, the whole cube, upon modulus of 2 plus I into modulus of 1 plus 2i. And we all know what is the formula for modulus. It is under root of a square plus b square. Correct? So 1 square plus 1 square, here it will be under root of 2 square plus 1 square. And here same into under root of 1 square plus 2 square. So here in numerator I'll get 2 raised to 3 by 2, correct? Upon, in denominator 5 plus 5. So this is my answer. We can write it as 2 root 2 upon 5. Correct? So these are some nice use of properties of modulus. Let's move on to the next one. Can you read it? Please note that pi by phi is argument of z1 bar. And you might know that z1 bar, the argument is pi by phi. That means the point z1 bar is situated here. And this angle is pi by phi. You might know if z1 bar is here, then where will be z? Z will be exact mirror image of x-axis. So z will be here, z1. And if it is exact mirror image, so this is pi by phi. This will be minus pi by phi. Why minus? Because we are going clockwise. So clockwise mein minus. So that means this is z1. So what is the argument of z1? It is minus pi by phi. So that means this will be minus pi by phi plus argument of z2. z2 का तो डायरेक्ट ही दिया है pi by 3. So this means pi by 3 minus pi by 5. That is 2 pi by 15. Got it? This is an important concept. If you don't remember it, so let me make it clear. If suppose there is a point here, which is z, then exact reflection in y-axis, here will be a point which is z bar. And here exact reflection in the third quadrant, here will be a point minus z, which is the reflection of this. And exactly above it, as we can see, it will be minus z bar. So basically this forms a square. Got it? So these are the positions. If z is here, z bar will be reflection in x-axis. And same ulta. If z bar is here, then z will be reflection in x-axis. Got it? So that only we used here. I hope you got it. Clear? Hai? Chalo, let's move on to the next question. Find the value of argument of z plus argument of z bar. Same concept we'll use. Again, let's say z is here, then z bar will be here. If this is theta, then this will be minus theta. The argument of z will be theta plus argument of z bar. What is argument of z bar? It is minus theta. So theta minus theta will be 0. So if you know that simple concept, logical concept, we can directly get the answer in just under 10 to 15 seconds. Got it? So let's move on to the next question. Yeah. I hope you know the properties of argument. The properties of argument are same as compared to log. So that means argument of z1 upon z2. I can easily write it as argument of z1 minus argument of z2. Now what is z1? I can write z1 as minus 1 plus 0i. So what will be tan theta? It will be 0 upon minus 1, which is 0. That means theta 1 will be equals to 0, which is argument of z1. What is z2? z2 can be written as 0 plus I. So that means tan theta 2 will be 1 upon 0. Correct? Which is not defined. That means theta 2 is equals to pi by 2. What does this mean? Theta 1 is argument of z1. Theta 2 is argument of z2. This means this is 0 minus pi by 2, which is equals to minus pi by 2 is my answer. Simple. Got it? Chalo, let's move on to the next question. You must have done many questions like this. Why? Because these are standard questions based on powers of I. What we have to remember is I square equals to minus 1, I cube equals to minus I raised to 4 is 1. These things you have to remember. So let us write it like this. So I can write it as I can write it as I into I raised to power 56. Correct? Plus 1 upon I into I raised to the power 124. So that means I'll get I into I square raised to the power 28 plus 1 upon I into I square raised to the power 62. So I square is minus 1 raised to even power is plus 1. So this is I plus 1 upon I. And what we'll do here, we'll basically conjugate. We cannot afford complex number in denominator. So I'll get I minus I. This will be I square. I square is minus 1. So I'll get minus I, which is equal to 0. What a nice answer. I minus I, which is 0. Let's look at the next question. Oh, we had options. So this is option A. Got it? Chalo. I would like you all to try this. This is also a classic question which almost everyone does. There is nothing very tough here. You can see we can take I raised to the power 10 common from numerator. If I take I raised to the power 10 common from numerator, what I'll get is I raised to the power 582. I hope you are getting it. 580, 578, 576, 574. And the same thing is written in denominator. So this will get cancelled. -1 भी तो है. So I raised to 10. I raised to 10 is I square raised to 5 minus 1. -1 raised to 5 minus 1, which is -2. So what option it is? It is option 3. I hope it is clear. Let's move on to the next question. Same least positive integer is. These are our options. Yeah. What is we have to find? We have to find the value of n such that this whole is positive integer. So let's rationalize. Whenever we see division, we'll simply rationalize. So if we rationalize, I'll get 2i upon 1 plus I into 1 minus I upon 1 minus I raised to the power n. Is it clear? So here in numerator, I'll be getting 2i minus 2i square upon a square plus b square. So we can take 2 common, right? So this will be 2i plus 2 upon 2 raised to the power n. I hope we didn't make any mistake. 2i into 1, 2i into minus I minus 2i square. 1 plus I will get 1 plus I raised to the power n. Now, this should be an positive integer. So what is the value of n? Let's check the options. If I get n equals to 2, that means 1 plus I ki power 2, which is 1 plus 2i a square plus 2ab plus I square. So this is basically 2i. So n equals to 2 is not valid. Then n equals to 4. N equals to 4 means 1 plus I raised to the power 4. That means what was 1 plus I raised to the power square? The whole raised to the power square. So what is 1 plus I the whole square? 2i raised to square, which is 4. I square, which is -4. Again rejected because we want positive integer. So let's try n equals to 8. So 1 plus I raised to the power 8, which is 1 plus I. Wait a second. 1 plus I raised to the power 4 raised to the power 2. What is 1 plus I raised to the power 4? -4, the whole square, which is equal to 16. We got our answer. 16 means a positive integer. That means n equals to 8. Option number 3. I hope it is clear. Let's move on to the next question. We already did this question, if you remember. 10 seconds. What was its answer? Already did it, right? No need to do it again. We cubed on both the sides, then compared real and imaginary parts. If you remember, what is the answer again? It is second. Got it? Chalo. No need to solution. This is a good question. Here, what is the ask is, see, we have to ask this. We have done this kind of question, but let me tell you, here we'll be using more trigonometry. Whenever a complex number comes in the form of cos theta and sin theta, we'll mainly use the trigonometric formulas. So, let's see what are the options. These 4 are the options. Now, according to me, we'll use trigonometry. So, what is 1 plus cos 2 theta? 1 plus cos 2 theta is 2 cos square theta. plus I times. What is sine 2 theta? Sine theta is 2 sine theta cos theta. Now, is something common? Yes. What it is common? 1 upon 2 cos theta is common. I'll get cos theta plus I sine theta. And whenever a complex number comes in denominator, we multiply and divide by conjugate. So I'll multiply cos minus I sine upon cos minus I sine. So in numerator, I'll be getting cos minus I sine upon 2 cos into a square minus b square, so cos square plus sine square, if you remember, which is 1. So basically I got cos minus I sine upon 2 cos upon 2 cos. So here cos and cos will get cancelled. I'll get 1 by 2 minus. Here sine upon cos is 10. I by 2 tan theta. What is the option? Is it option available? Yeah, it is option A. This is the correct answer. I hope you are getting it. Let's move on to the next question. Now, see this closely. Again, the complex number given to us is in division form. Two complex numbers are getting divided. This means we have to multiply and divide by conjugate. Simple. So, I'll get 3 plus 2i sine theta upon 1 minus 2i sine theta into, what is the conjugate? 1 plus 2i sine theta upon 1 plus 2i sine theta. What I'll be getting in numerator, I'll get 3 plus 6 plus 4. I'm writing direct. This is fine. So 3 to the 6i plus 2i. 6i plus 2i. 8i sine theta plus 4i square sine square theta upon denominator में a square plus b square. So in numerator, this is minus 1. Basically, I got 3 minus 4 sine square plus I times 8 sine theta upon 1 plus 2 sine square upon 1 plus 2 sine square. What does this mean is purely imaginary. Purely imaginary means real part of z will be equals to 0. What is the real part? This is the real part. So that means 3 minus 4 sine square upon 1 plus 2 sine square will be equal to 0. If we cross multiply, I'll get 3 minus 4 sine square equals to 0. That means sine square equals to 3 by 4. So sine theta is equals to root 3 by 2. Find the real value of theta. That means, acha, we can use plus minus, na? So that means I'll get theta as, we can write the general solution, right? N pi plus minus what, pi by root 3 by 2 is given pi by 3. This is my answer. N pi plus minus pi by 3. I guess we have options here. Yeah. So my option is option second. Got it? Chalo, let's move on to the next question. Let me drink some water. Till then, we look at the next question. Again, same concept pe based. Here it is given. This is purely imaginary. If this is purely imaginary, that means it will not have the real part. So I can say 5z2 upon 7z1 is equals to some bi. It will not have I. That means z2 upon z1 is 7bi upon 5. I can write it as, see, I need z2 upon z1 to appear. So if I need z2 upon z1 to appear, I'll divide numerator and denominator by z1. That means I'll get 2 plus 3z2 by z1 upon 2 minus 3z2 by z1. Let's substitute the value. So I'll get 2 plus here. 7th is a 21 bi upon 5. So 21 bi upon 5 upon 2 minus 21 bi upon 5. What is the modulus ka formula? Sir? By property we can split the Acha, no problem. By property we can split the modulus. What is meant by modulus? Let me tell you one interesting thing. If I consider this, let me change the color, you'll understand it more better. If I consider this as Z, if I consider it as Z, then what is this? खाली I की जगह पे minus I आ गया ना? This is basically Z bar. So what I am given is, I am given mod of Z upon mod of Z bar. And as we already discussed, कि मॉडुलस में z और z बार की वैल्यू सेम होती है, it will be 1. My answer is 1. This is a smart way of looking at the question. I hope you understood. Oh, we have the options also. What is our option? Our option is 3, which is 1. Let's move on to the next question. An interesting question and the last question for today. What is log of minus I? Actually, if you see, this question will be done after we do the exponential form of complex number. So we'll do it next time. Let's skip it for now. Because we can do, I know you all know that the exponential of complex number is there, but we keep it for tomorrow. So my final question will be this. Yeah. It is a very simple question and very much asked. And I will show you the theoretical way. In the next lecture, we will see geometrical way. So here it is given. What is the locus of this? And z ka value is given x plus iy. Z ka value is given x plus iy. Barabar? So the options are one second. Yeah. The options are A, B, C, and D. Now, this is a very simple question. Let's just substitute the value of z here. So what I'll get is x minus 1 plus iy. I simultaneously grouped and I'll simultaneously cross multiply x minus 3 plus iy. Got it? And we don't require mod, that means we'll square. What is modulus ka square? It is x minus 1 the whole square plus y square का अंडर रूट आएगा, but since we already squared, वो अंडर रूट क्या हो जाएगा? Cancel. Is equals to 4x minus 3 square plus y square. It's all done and dusted. We just have to open the bracket and see which option it matches. Let's do it. X square minus 2xy plus 1 plus y square is equals to 4 times x square minus 6xy, 6 for the 24x plus 9 for the 36, correct? Plus 4y square. So if we take everything on the right hand side, I get x square minus 4x square, 3x square, 4y square minus y square, 3y square, minus 2xy, minus 24. So minus 22x. And lastly, 36 minus 1 will be plus 35 equals to 0. This is my answer. Could you guess it? Which option it is? Option number 2. So I hope today's lecture was somewhat beneficial to you by solving the questions. You also got some practice of complex numbers. It is an important chapter. Why? Because one question for complex number is fixed. Like every year they ask at least one question is fixed. Means one question means 4 marks, and 4 marks, I know what is important to you. It'll shift the rank by many things. And usually complex number questions are generally simple. No need to stress about it. Just revise what we'll do today and tomorrow, and you will be prepared. Okay, thank you all. Thank you, everyone. We'll meet tomorrow.